Hello everyone. In this lecture, I'm going to discuss a challenging problem from LG book. This is based on carboxylic acid. The question is, a student synthesized compound 1, that is this one. To purify this compound, he extracted it into aqueous base and then acidified the solution to protonate the acid so that he could extract it back into ether. When he evaporated the ether, he found that his product, that was 1, has been converted entirely into compound 2. Okay. So on the basis of that, we have to answer the following question. The first is, what are the functional group that forms the ring in compound 1? Okay. So basically the functional group in the compound 1, we can see here it is. We have this functional group, this one entire, that is basically acetal functional group because there is hydrogen. So this is acetal functional group. One more functional group we have is this one, COOH, that is carboxylic acid. Okay. So these are the functional group that are present in ring 1. Okay. In compound 2 also we have to find the functional group. So let's see. This one is the first functional group we have, that is ester. And this ester is in a ring, which is also known as lactone. Ester in a ring is known as lactone. Another functional group that we have, here it is. This is alcohol. Okay. So the first one was very simple. They just asked you to find the functional group present in ring 1 and 2. Okay. Let's see the next one. How many carbon atoms are there in compound 1 and in compound 2? Where did the other carbon atoms go? Okay. So if we see the compound 1, the carbon atoms are present at this position 1, 2, 3. This one is 4, this one is 5, 6, 7 and 8. So there are 8 carbon atoms in the compound 1. Okay. We can, say it like this is the first one, second, third, fourth, fifth, sixth, seventh, eighth. These are the 8 carbon atoms that is present in this compound 1. Now in compound 2, we have to figure it out. So in this case also, we have this is the first carbon, second, third, fourth, fifth, sixth. So in the second molecule, we have only 6 carbons. So we have here 6 carbons. Okay. Where did the other carbon atoms go? So now, if we see carefully, there is the acetal, group present here. This acetal group will be, undergoing reaction that we'll see later. And these carbon atoms, that is this one and this one, will get removed from this molecule. Okay. Now, coming to the next one. When did the reaction occur? When the student added the base or when the student added the acid? Now, if you see the first molecule here, this is the first molecule. When the student will add the base, what will happen? This is acetal. And we know that acetal are stable to base. Acetals are stable to base. So when the student will add base, okay, acetal will not be cleaved. Okay, only it will be acid-base reaction will take place. This acidic group, that is carboxylic acid, will react only, and the product you might get is this one. Just the acid-base reaction product will be getting. That's it. Okay. So since acetals are stable to base, hence acetal must have cleaved when the student was adding the acid. So we can conclude that acetal must have cleaved, okay, after or when acid was added. When acid was added. Because base, if you add, we have seen this reaction will occur. So no change will be there. Okay. So third one also done. Let's say the last one only is important, and yeah, will be coming under that category. So propose a mechanism for the conversion of 1 to compound 2. Basically, we have to propose the mechanism, like how to convert A to 1 to 2. Okay, so let's see. We'll draw both the molecule now. First we have this one, CH3O, okay, methyl, and CH2COOH. Okay, this is one, and that is going to convert into this molecule when we add the acid, basically. So we have to now propose the mechanism. Okay, so as we know that acetals will react with the acid. So first what will happen, this acetal group will react with the acid. So this oxygen has lone pair, it will react with that acid. H plus will be coming from the acid, basically. Okay, and this will get protonated. This will get protonated to this. Yeah. This will get protonated. After this protonation, this bond will break because it will be too much polarized. And we will be getting this. And we will generate this carbocation. Now this carbocation can interact with water molecule that is present in the reaction mixture to give the further compound that we have is this one, OH2 plus. After that, there will be proton transfer. This proton can be transferred to this one, and we can have this molecule now. Yeah. Then again, there is a chance of cleavage of this bond. This bond will be cleaved, and what we are going to get now, it is acid, basically. It is acid, CH2COH, right? Now, and this will convert to what? A carbocation, that is this one. Okay, which can again take water to form isopropyl alcohol. This can take water to become this. not isopropyl alcohol. Let's see, this will form this alcohol. Yeah, gem diol basically. Geminal diol it will form. Okay. And which can further, release water because gem diol is unstable. So it will release water to form what? CH3, COH, acetaldehyde. So this is the byproduct basically. We have to focus on this one. What is the further reaction of this? This is acid group present in that, and that is alcohol. So there is a chance of, intramolecular esterification. Intramolecular esterification. Esterification will take place. So in esterification, well, already we know this, the loss of water takes place. This OH and this H will be lost. And this carbon, number 1, and this oxygen, that is number 2, will form a bond. So if we count the number of atoms in that ring, it will be carbon. Let's start with 1, 2, 3, 4, 5, 6. A 6-membered ring will be formed. And let me draw the 6-membered ring. And it will be a cyclic ester like this. This carbon I have given as first, numbering, then second, then third, then fourth, then fifth, and this oxygen is sixth. On the third carbon, we have 2 group present. That is basically alcohol and methyl. So this is the final product that we will be getting after intramolecular esterification reaction. And that is the exactly same product that we have got there. That is cyclic ester, or we can say lactones. So that's the complete mechanism of this reaction. Thank you.